What you're looking at here is our development workstation, where we will be developing the control unit for the Swamps Diesel injector driver module, which you see right here. We'll be using a 2560 Atmel processor. We'll have a four line by 16 character display and a keypad. This will all be mounted in a enclosure. Up here you see a schematic, what the inside of the IDM Injector driver module looks like, and as you can see our various computers and things. As I said, this is the processor, the keypad, the display. Up here, which is important, we can look. This is the waveform that it's actually quite complex. These injector, these hydraulic injectors have a coil in them, solenoid that has approximately a 3-ohm resistance. So if you apply 110 volts across 3.2 ohms, you're going to have up to 34 amps of current, which if left continuous would burn out the coil. So the electronics of this are fairly complex. So it starts out for a short period of time with the full DC voltage applied, and then the control unit goes into this oscillation mode, because at this point in time the injector is actually the solenoid is actually pulled in. So it requires, once it's pulled in, it requires a significantly less holding current, and this is what this waveform, there's a dead spot, there's a little more holding current, and then the signal terminates. So it's a fairly complex system, and this is why it's important that we use the Swamps Diesel. Now, here we have a variety of inputs and outputs. There's inputs that indicate which series of injectors based on the time. This is designed for an 8-cylinder V8 Ford diesel engine, and you have all of the outputs in the ground for each injector. You drive four sets of injectors separately, and the processor will be providing the input control signals to do that. In addition, it will be monitoring the RPMs of the rotary expander. There'll be Hall effect sensors mounted on the shaft so that we know exactly when to inject direct the output of the impact chamber at just the right time. So, and we'll be simulating those signals with our waveform generator here. So, anyway, once all this is worked out, which should be relatively soon, we'll bring this whole system up to Florida Microelectronics and actually connect it to our injectors with the completed impact chamber. So that's where we're at the moment.